Congruent figures are figures that have the same shape, same size, and they also coincide together. So basically everything about the shapes, the figures are the same. Today we are not talking about congruent figures, but rather congruent triangles. Triangles that are exactly the same. Congruent triangles! When triangles are congruent, 6 facts are always true. The corresponding sides are congruent. The corresponding angles are also congruent. We will be using these color stripes and other things to help you understand congruent triangles better. If you are dubious about anything in the explanation section, try it out yourself. The first method is side, side, side. If you only know 2 side lengths, here we have the yellow one and the blue one, you can position them in any way. It can basically go on forever. So the missing length is undetermined. If you know all 3 sides of a triangle, there is only one way of how the triangle is going to look like. So that is why you are able to find if the triangle is congruent to another triangle just by the side, side, side. The second method is side, angle, side. If you had a set length for the yellow stripe and the blue stripe, and you know the angle in between them, you are able to have something like this. Just by inspection, you know how long the third side is going to be, right? So of course, this white stripe does not fit. On the other hand, this new white stripe works. It's just long enough to reach both sides. If you know one side, one angle, and one side exactly in this order, there is only one way of how it's going to look like. Therefore, another triangle with the same information is going to be congruent to this triangle. Method 3 is angle, side, angle. Here we have 2 stripes, a yellow stripe and a gray stripe. The length of the gray stripe is in centimeters. The angle in between the gray and the yellow stripe is x degrees. Right now, we couldn't determine the last side. If we have a randomized angle y degrees between the gray stripe and the white stripe, now we are able to have a triangle that is not changeable. Well, it is not changeable because of the 3 information, angle, side, angle. Okay, the reason I didn't explain all the methods was because they overlap. So you already have understood all the methods by the parts that you have seen. And here is a complete list of all the methods. Just read them over so you know them all for further usage. It's some problem time. Alright, so here we have 2 triangles, and with all the information out there, are you able to find if they're congruent or not? This is kind of easy, so I'm going to give you a few seconds to think about it. So do you have the answer? Well, it's just been a few seconds, so I don't think you are able to get the answer right away. But anyways, I'm gonna explain this to you. So the key thing is 180 degrees and these 2 turquoise angles. The turquoise angles are not the same. They're in the same color just because you get them basically at the same time. So from these 3 key things, do you now know how to solve it? Okay, I'm gonna explain this more. So as I have said, the 180 degrees. So you're gonna minus the shared 45 degrees. Because that gives you 135 degrees, which is this angle plus this angle, or this one plus this one, right? So basically, these two angles, it's the same as these two angles. It's way easier now, isn't it? Or I suppose it's way easier. So I'm just gonna use 55. I'm just gonna subtract 55. And guess what? It comes out to be 80 degrees. This angle is 80 degrees. And that means 55 plus 80 equals 135. And this is 55 degrees. So here are the complete information. Now are you able to find if they're congruent? What are the ways that you use? Are there multiple ways? Yes, there are multiple ways. There are only two ways. Here are the two ways. Oops. Here are the two ways. ASA and AAS. So basically, with this side that I haven't talked about, and any two randomized angle from each triangle, well, they have to be the same angle though, not like a different angle, right? So these two angle and these two angle, or these two and these two, or these two and these two. So you can just pick any two angle that coincide with this 10 centimeter side, and boom, you are able to prove that it is congruent. Now you may or may not find the previous question easy, but now we're working backwards. So triangle EGH is congruent to triangle FGK. HK is equal to 10 centimeters. HG is 4 centimeters. The question is, what is the length of EF? Do you know how to solve this question? Well, I assume no, but anyways. HK is 10 centimeters, HG is 4 centimeters, and that is super obvious that this part is 6 centimeters. So GK is 6 centimeters. And since these two triangles are congruent, EG is also 6 centimeters. That's why it's very important to know they're congruent. Now we don't really use this side and this side, just so you know, if you're thinking of that way. Okay, now HG is 4 centimeters, and right here, FG, it's the same, it coincides with HG. So if this is 4, and this entire thing is 6, EF would be 2, right? So 6 minus 4, it's the same as where EG minus FG. So that gives you the answer, which is Here are some of the things we learned today.